A very warm welcome to everyone this webinar. Good afternoon, colleagues, researchers, advocates, leaders, and friends. So I am Miles, and my main objective today is to give you highlights on what we discovered in our study on geospatial assessment of the urban heat island in Davao City. So what we are looking at is a simple illustration of urban heat island, or UHI. UHI occurs when a city experiences much warmer temperatures than nearby rural areas, just like in Davao City. So as you all know, a large part of Davao City is mountainous, characterized by extensive mountain ranges with an even distribution of highlands and lowlands. And the city southeast is surrounded by Davao Gulf. But why is Davao City selected as one of the priority sites of the project GUHeat? So the primary reasons are it's a highly urbanized city. It's the largest city in the Philippines in terms of land area, and it's the third most populous city after Quezon City and Manila. So in 2018, Davao City's annual average temperature ranges from 25 to 32.8 degrees Celsius based on observations by Pag-asa. Now, there's no doubt that urbanization has improved the well-being of societies. However, whether we like it or not, urbanization contributed to unintended climate modification. So in Davao City, its development such as buildings, roads, industries have directly and indirectly led to air and surface temperature changes. The spatial-temporal intensity of landscape change in Davao City can be assessed through remote sensing data. Here is the derived normalized difference built-up index, or NDBI, which highlights urban areas or developed lands. And here is the normalized difference vegetation index, which quantifies vegetation or plant greenness. NDVI is usually used to monitor vegetation health. Let's do a brief comparison in this area. As you can see, urban effects on the environment are present to a greater extent in Davao City and lesser extent in Samal City and Panabo City. Similarly, Davao City surrounding municipalities and cities, they have made developments wherein the original setting had been replaced by infrastructures, agricultural landscape, and plant settlements. Now, all these urban transformations and urban expansions are responsible with the urban heat. It is evident that the magnitude of average surface temperature is higher in Davao City than its neighboring areas. More particularly, the main urban center of Davao City has warmer temperature or warmer environment compared to less developed barangays. Then we also found a strong relationship between LST and these indices. Positive for NDBI, while negative for NDVI. So certainly, Davao City is exposed to extreme heat based on this reported news. In Project GUHeat, we have conducted further investigations to verify if there are micro UHIs or hotspots within UHIs in Davao City. I will be presenting first the evidences we found in the surface temperature. So on your screen is the spatial temporal hotspot and cold spot occurrence frequency map for the period 1994 to 2019 in Davao City. Expectedly, out the southeast of Davao, hotspots were dominated by these districts. Part of these neighboring barangays were marked as hotspots. Lastly, portion of these barangays had warmer temperatures. So this agrees with the distribution of land cover in these areas, which consist of dense low-rise to lightweight low-rise structures, compact open mid-rise buildings, then few scattered trees, and heavily paved roads. Now, why should we be concerned about this? It's because it is expected that in Davao City, there will be an urban expansion and correspondingly, hotspots will intensify not just in urban barangays. How so? We found out that there is a buildup of hotspots in the rural barangays of these sub-areas enclosed in rectangles. In the eastern Davao, urban LST hotspots spread to adjacent rural barangays. We confirmed that the land use type of these hotspots are industrial, residential, commercial, agricultural, and institution. Then, unexpectedly, in the west of Davao, we were dismayed to discover that there were hotspots present in the less developed areas near Mount Apo National Park, and are classified as prime agriculture, rural settlement, and conservation. These areas should be monitored regularly. Urban LST hotspots expanded in southern Davao and small communities in northern Davao. I would also like to mention that we obtained maps of occurrence of cluster transition. These display which areas in Davao City have transformed from cold spots to moderate to hotspots, and which areas have experienced double transition from cold spots to hotspots, meaning they have greatly engaged in development. So in this research, through quantile regression, we concluded that building index is the most significant variable at predicting land surface temperature in Davao City. So if value of building density rises by 0.01, LST will increase by 0.06 degrees Celsius. Okay, so another evidence of UHI in Davao City was found in the air temperature. Last year of April, we deployed 2 Hubble water logger sensors to capture the air temperature in the city's main urban center. While one was stationed in UP Mindanao in Barangay Mintal, also an urban barangay, but with a rural kind of environment. There are 2 major findings here. First, air temperature is higher during daytime than nighttime to dawn. UP Mindanao has alternating increased degrees shape. Also, it is warmer during daytime because the sensor was attached at an area more exposed to sunlight. But its temperature greatly cooled down at around 4 p.m. already. Second, UHI phenomenon is more obvious during nighttime until dawn than daytime. So let's take a look at this particular temperature reading. There is about 4.21 degrees Celsius and 3.82 degrees Celsius difference between UP Mindanao and 2 urban stations. We conducted another data gathering in the air temperature of Davao City, but this time we focused on the downtown area, particularly in Davao City Hall Complex and Claveria Street, where we installed 11 Hobo onset data loggers. Similarly, regardless of the station, temporal variations in air temperature show that it is warmer during daytime and then gets cooler by nighttime until dawn. Now, if we conduct more analysis in this graph, specifically this part, we can see that stations 2 and 10 have higher temperatures despite of this station's surroundings. So this station, sensor 2 was installed inside the Osmeña Park, while sensor 10 was attached to a mini store beside the Institute of Psychiatry and Behavioral Medicine Park. So we looked into possible answers of these unusual readings. We found out that station 2 is actually short distance away from the generator transformer, which normally runs between warm to very warm temperatures. Meanwhile, in station 10, there is a possibility that a bulb or a candle is inside the mini store. Plus, there is heat coming from a power exhaust fan outlet of Gaisano Mall. So these results indicate that the cooling effect of parks in these 2 stations was not effective enough to overcome the factors that I just mentioned earlier. So to support these claims, I will give an illustration that could answer this question. At what maximum distance a park can provide its cooling effect? So for example, People's Park, which has an area of about 3.7 hectares, its cooling effect reached at 0.38 or Pasalubong Center with a distance of 20 meters away from the nearest tree in the park. However, the cooling effect of the trees was not reflected in 0.46 surface temperature readings. Its distance from 0.45, which is just few steps away from the park's gate, is 30 meters. Now, another example is Osmeña Park, which is about 7 times smaller than People's Park. So if a person is standing at this red balloon and walks towards San Pedro Cathedral at this particular path, at what distance would he start to feel warmer air temperature relative to the air temperature in his location? The answer is 9 meters. We observed that the cooling effect of Osmeña Park started to decrease at 9 meters. Also, its cooling impact was no longer felt at 25 meters. Meanwhile, the cooling effect was more evident at 5 p.m. and is expected to continue until nighttime. So we postulated that as the vegetated area increases, the lower is the temperature around it, and the effects are more prominent the closer to the vegetation. Increasing the area of vegetation can indeed mitigate the urban heat. And I think later you will know more of the simulation results, the spatial distribution of hourly air temperature, which will be presented by the next presenter. Now, you might be wondering why there are temperature differences. Say, Davao City Hall complex, for instance, when we had our hourly measurement of surface temperature of different materials. So we observed that surface temperature of materials, such as these 4 categories, are extremely varied, especially by day, despite of its similarities, whether it be form or feature. Likewise, surface temperature of these materials, metal, plastic, rubber, vegetation, and water, have different morning measurements. So this is the combined line graph. Generally, we notice that the surveyed materials peaked at different time between 8 to 12 noon. Then some materials already cooled down as early as 10 a.m. So going back to the question, why is there a temperature difference? We should understand that there are various factors affecting the warming and cooling of the temperatures of each material. First, the capacity of heat, which expresses its ability to store heat. Water, for example, having high heat capacity, just mentioned by Sir Ariel earlier, is great at storing heat. In other words, it takes a lot of heat before it begins to get hot. That's why water fountains are placed in parks. Aside from the fact that it's a delightful scenery, they can also provide refreshing surrounding atmosphere and can improve the thermal environment. However, it also implies that water takes longer to cool down, which may result in water bodies like lake being warmer than adjacent land during night. Second would be the thermal conductivity. An example of material with high thermal conductivity is metal. For instance, roofs made up of galvanized iron sheets metal. So when these roofs are exposed to sunlight, they easily become warmer. And then when these roofs are covered by clouds, in an instant, they will cool down quickly. Third is radiative properties of materials. So impervious artificial dark surfaces, such as traditional asphalt, which is low albedo, by its nature greatly absorbs all wavelengths of light energy and converts them into heat. And since the structure of asphalt is dense, it retains that heat not only during day, but also at night. On the other hand, lighter colored materials such as concrete and coated streets generally have higher solar reflectance. So they reflect heat from the sun back into the environment. they still warm the environment, the temperature, but slightly lower relative to asphalt. So another significant factor that contributes to the rate at which a material will cool down is the presence of vegetation. Trees have great potential to cool cities by shading, and of course by evapotranspiration. So evapotranspiration is basically combined loss of water to the atmosphere by evaporation, which comes from soil, and transpiration, which comes from leaves of trees and plants. So to put it simply, vegetated areas work like a natural air conditioner. So other drivers on the formation of heat islands in cities include, but not limited to, moisture availability, which is closely related to surface permeability, geometric form, or structure, example, building orientation for shading and airflow, and of course, anthropogenic activities. So as I have mentioned earlier, urbanization in Davao City had contributed to changes of air and surface temperature. And in turn, exposure to extreme urban heat has direct and indirect impacts on the quality of life and environment. So the effects of UHI are as diverse as its causes, but for today's webinar, I will focus only on these three. So what would be the relationship of surface temperature and electricity consumption in Davao City? So here's a map of power consumption users in Davao City. Elevated temperatures, especially during dry season, increase energy demand for cooling. So to verify, we first obtain the annual total power consumption per type of user for the period 2008 to 2017 from the Davao Light and Power Company. Industrial group has the highest consumption despite having the fewest number of users, 1.26%, followed by residential, which has the largest count of customers, about 86.15. Then commercial with 12.56% of the total users consume the least electricity. So what we can notice is that electricity consumption of commercial and residential users have very gradual linear increase, while industrial has slightly steeper linear increase. Meanwhile, Landsat 8 satellite data was used to derive the average LST values for each type of user for the period 2008 to 2017. The average land surface temperatures of commercial, residential, industrial areas have alternating increase and decrease in values. And a similar form can be observed with a very slight deviation for commercial areas that's between 2008 and 2012. So correlation analysis was done individually for commercial, industrial, and residential. And the results show that there is a strong positive relationship between annual average LST and total annual electricity consumption per type of user. So this means that the increase in LST has a probable effect in the increasing of electricity consumption. So the warmer it gets, the more we use air conditioning. Now, as you all know, one of the sources of energy is power plants. And we are all aware that fossil fuel power plants, they burn fossil fuels such as coal, natural gas, or petroleum to produce electricity and largely contribute to air pollution and greenhouse gas emissions. So another sources of pollutants, particularly particulate matter 2.5 micrometer or PM 2.5, they come from factories and vehicles. PM 2.5 poses the greatest risk to health because these are very fine particles which can get deep into our lungs and some may even get into our bloodstream. So in Project GUHeat, we were able to obtain the count of PM 2.5 in some areas identified as surface temperature hotspots in Davao City. So high readings were recorded outside of the People's Park, Quirino Avenue, Palma Hill Street, Rojas Avenue near the Ateneo de Davao University, Magsaysay Avenue, and Santa Avenue near the Gaisano Mall. Whereas People's Park have consistently low readings. So high PM 2.5 readings were also recorded from intersections and high traffic volume areas. Now we are down to our last topic. Of course, nothing can be more felt than the direct effect of urban heat island on human lives. So we have conducted an outdoor thermal comfort survey to some residents and visitors of Davao City last January this year. A total of 90 interviewees. Their age ranged from 9 to 73 years old. And based on the results of thermal sensation votes, about 32.22% and 23.33% of respondents answered they felt warm and hot respectively. Moreover, 18.89% of the participants, they felt very uncomfortable, while 43.33% thought of their thermal comfort as just neutral. Lastly, 11.11% of the respondents preferred much cooler temperature, however, mostly favored cooler temperature. So before I end my presentation, here are just some of the photos of our outdoor thermal environment survey in Davao City last August 2019. The project used a radiometric thermal camera. So on your left screen, this was taken at Claveria during the interview. And on your right screen, this was captured in People's Park. This, I believe, in City Triangle and Freedom Park, Rojas Avenue. Then some buildings at Claveria. So in summary, based on the evidences that we just showed, there are threats to the urban habitats in Davao City. And we need to combat this through effective yet sustainable planning. So if we were not hesitant in enjoying all that urbanization has to offer, may we also not be hesitant in mitigating its effects. And that's why we invited speakers from the executive branch, non-government organization, and professional organization, who is also in academe, to share with us their perspective in having a comfortable and healthy urban living. Finally, I would like to express my sincere appreciation to the following people and offices. That would be all. Thank you.